Welcome to This Medical Life podcast. These are the stories of medicine with Steve Davis and Dr. Travis Brown. And this is the story of lactose intolerance. All right, Travis, I have put down my milkshake. I am all ears.
So we're talking about lactose intolerance. And in Australia, actually, when we talk about lactose intolerance, it's kind of a bit strange. And the reason why I say it is we show our cultural bias here.
Oh.
And the reason why we talk about it is because 80% of Caucasians have lactose tolerance. So there is actually a small percentage of Caucasians who are lactose intolerant. Mm. But the majority of the world actually is lactose intolerant.
The majority?
The majority. So about 2/3 of populations around the world can't metabolize lactose after their children. Geneticists actually call this lactose persistence. And so there's actually more, Caucasians have more lactase persistence than the other way around looking at it.
So we're not normal.
The Caucasian people
Yes.
have more lactose tolerance than other races.
Making us outliers.
That's right.
In the world population.
That's right. And so when we look at this, so the ability to metabolize lactose is actually racially based. And so if you look at it, 100% of Asians, 70% African Americans, East Indian, US Hispanics, and 50% of Spanish and French are lactose intolerant. If people from there have lactose or they drink milk, they will get symptoms of ingestion problems, malabsorption, and all the symptoms people are actually quite familiar with. And so we have, if we look at through, just these different ethnic backgrounds, there's a really interesting natural experiment that happened with the Maasai people. And they're from East Africa. Now, they arrived in the savannah 4 centuries ago. And they live a migratory pastoral life. And their society is heavily focused or ingrained with cattle. And so the cattle has a cultural significance, it has religious significance, and it's also their economy. And so their god, Enkai, believed the cattle were sent down from heaven down a rope and was given to them for them to protect and use. And so the men are warriors and they protect the cattle from predators, and they herd the animals to water and pasture lands. The women are home life, and so they milk the cows and they raise the children. Now, the Maasai use cattle pretty much for everything. So they use it for clothing, they use them for sheltering, they use for cooking utensils like their ribs are spoons, horns are cups. And they use for currency, they have a barter economy. So you're actually bartering and transferring cattle as your money. And they also use it for food. They use milk, they use dairy products, they use beef, fat, and blood. And so their whole culture revolves around cattle and the use of milk and milk products. Now, from their heritage, you would expect their lactose persistence
to be strong.
Well, no, because their heritage. So because they're African, you would expect their genetics to only have like 20% of lactose tolerance or persistence. So the majority you would expect would actually get symptoms from this. However, there was a study done in 2012 that showed their lactose persistence was about 60%. So that's from 20%, which you would expect from their genetics, from their heritage genetics, has gone up to 60%.
So 3 times greater than the average African.
What you would expect, yeah. And so they did some genetic testing, and they showed this persistence was by some known lactose mechanisms, but also some novel genetic polymorphisms. And so there they concluded that this dietary tradition has selected for tolerance over the generation of about 150 to 400 generations. And so in genetic standards, that's actually really short when we're talking, thousands of years. Well, they've done it over about 400 years. And so what we're looking at from our perspective in medicine is there's two kinds of ways that we can test for lactose intolerance. There's a chemical way, so we can challenge people with giving you lactose and see how you actually respond. Or we can do the genetics. So this episode, we're actually talking to a chemical pathologist as well as a genetics pathologist and really sort out how do we test, how do we understand who is lactose intolerant, who has lactose persistence, and see if we can get some clarity around this.
I'm sure the cream will float to the top. Dr. Michael Page is a chemical pathologist and Chief Executive Officer at Clinipath in Western Australia. His areas of interest include cardiovascular risk and disease, including lipid disorders and hypertension. Michael's a senior lecturer at the UWA Medical School and an examiner for the Royal College of Pathologists of Australasia. He's also the president of the Australian Medical Association, WA. And Michael is our guest here on this Medical Life podcast. Michael, welcome.
Thank you very much.
I'd like to start at the very beginning here. How does the human body use lactose?
Lactose is a sugar. It's a sugar referred to as a disaccharide. In other words, it's a sugar that comprises two monosaccharides linked by a bond, and those sugars are glucose and galactose. So in people who have lactase activity in their small intestine, in other words, who have the enzyme in the gut that can separate those two monosaccharides, those two sugars are separated in the gut and they're absorbed via the small intestine, whereby they find their way to the liver. Galactose is converted by the liver into glucose, and the glucose can undergo the many interconversions, can be used to make energy, protein, fats, and so on. So if you don't have sufficient lactase activity in the small intestine, in other words, you don't have the enzyme that enables you to break down and absorb the components of lactose, the lactose finds its way from the small intestine to the large intestine or the colon, where the normal flora, the bacteria normally present in the large intestine, metabolize the lactose into short-chain fatty acids and hydrogen gas. And that's what causes the symptoms of lactose intolerance in people who lack the lactase enzyme in the small intestine.
So what are the common symptoms patients will present with?
Patients with lactose intolerance, and it's important to distinguish lactose intolerance from lactase deficiency because, of course, not everyone who lacks lactase in their small intestine will present with symptoms of intolerance for a range of reasons. They might not have a lot of lactose in their diet, or there might be other factors relating to the sensitivity of their large intestine to that lactose load, that unmetabolized lactose load. But those that are sensitive to that lactose and lack the lactase enzyme, generally within a few hours of eating, they'll experience abdominal pain, a feeling of bloating, flatulence, nausea, diarrhea. And generally, after a meal that contains enough lactose to provoke those symptoms, perhaps a decent-sized glass of milk, for instance, whereas, the tiny amounts of lactose that you might find as components in medications, for instance, are not generally sufficient to provoke symptoms. So people with lactose intolerance generally don't need to read the fine print on tablets and things to avoid all lactose.
Now, we break it into three categories, lactose intolerance, into primary, secondary, and congenital. Can you help us distinguish between these?
Yeah, sure. So clinically distinguishing between these is generally on the history. Primary lactase deficiency or lactose intolerance generally refers to those patients who don't have, and to introduce another term, who don't have lactase persistence. In other words, those people who are genetically programmed to switch off their lactase production from around 4 or 5 years of life. And that's very common in people from Asian or African ancestry. And it's much less common in people of Northern European origin. So people from Northern European ancestry typically have lactase persistence or much more likely to have lactase persistence. In other words, they're unlikely to be lactose intolerant, whereas people from Asian or African backgrounds are far more likely to be lactose intolerant. So congenital lactase deficiency is, in a sense, a form of primary lactase deficiency, but it's fairly uncommon. It's an autosomal recessive disorder where lactase activity is completely absent from birth, and that's a much more severe phenotype. These infants will present with severe diarrhea early in life, and they're potentially susceptible to some other medical complications as well. Secondary lactase deficiency, on the other hand, is where a person might have genetic lactase persistence. In other words, they have the enzyme to metabolize lactose, but for some reason they're not able to metabolize or absorb the lactose because of some other small intestinal problem. So that's common in people with celiac disease, particularly if it's sort of unmanaged or undiagnosed celiac disease, people with small intestinal bacterial overgrowth, and in patients with Crohn's disease, for example.
So we have a test, a chemistry test, when we're actually wanting to pretty much challenge the patients. It's called the lactose tolerance test. Can you tell us how it works?
Yeah, so the lactose tolerance test is an older type of test for lactose intolerance. The patient takes a lactose load orally in a liquid form, a little bit like a glucose tolerance test, really, and then has a series of blood tests over a couple of hours to check their blood glucose level. So the premise here is that if you can't metabolize the lactose, you won't then convert it to glucose, absorb the glucose, and have a spike in blood glucose concentration in the couple of hours after taking the lactose load. So what we're looking for is a rise in glucose that indicates that lactase enzyme was functioning properly and the lactose was metabolized. But a really important part of this test is for the patient to also record any symptoms they experienced during the testing period in the couple of hours after the lactose load. Because you need those symptoms to be present to prove that there's actual lactose intolerance. You need to have those symptoms provoked, because a positive result demonstrating lactose malabsorption, in other words, that glucose doesn't rise, so you've got lactose malabsorption in the absence of symptoms during the test, means that you might not have actually found a cause of the symptoms that prompted that patient to be referred for the test in the first place. In other words, it's more or less an incidental finding that they've got a lactase deficiency, but it might not be the cause of the symptoms that cause them to be referred if they don't experience the symptoms during the test after ingesting this, large whack of lactose as part of the test. On the other hand, some patients will have a negative result on the test, but nonetheless experience symptoms after the lactose load. So that could indicate some other mechanism for their symptoms, including, what's referred to as a nocebo effect. They were expecting it to cause them symptoms and then it did, or indeed a true false negative result, which can occur.
One thing that has staggered me through the history of this medical life is the detective work involved in various branches of medicine. Michael, this sounds like incredible detective work that you're involved in getting to the bottom of these diagnoses. And
lactose intolerance can be a particularly difficult condition to diagnose because some of the tests are imperfect, and the patient history here is really key to making the diagnosis. And sometimes it's a matter of, despite having these tests, some of which are very good and some are less good. Sometimes it's a matter of just trial and error with the patient's diet to see what works for them and what doesn't. And even if you can't prove they've got a lactase deficiency, if they experience symptoms, if they experience no symptoms off a lactose-containing diet and a lactose-free diet is acceptable to them, then of course that's going to be the solution for them.
I was amazed when I did all my reading on this, because when someone walks in with lactose intolerance, we say, well, go and have a lactose tolerance test. We challenge them and we give them a very good dose of lactose. Now, it's 50 grams of lactose, which is equivalent to 1 litre of milk, like sugar. And I'm like, is that, and then they potentially have symptoms. I was quite surprised about the dose that we give when we do this.
Yeah, look, and it's not actually. There's not a huge evidence base for the dosing. It's really just a good amount of lactose. That if they're truly lactose intolerant, they ought to get some symptoms. So it might seem a little bit cruel and unusual for people.
The other thing is we test for an elevation of 1.5 millimoles per litre of glucose. Now, can that happens potentially over a few hours? Is that a really good, reliable measure for that?
It's a good question, because it's not, for those who look at glucose results all the time, it doesn't strike you as being a big increment in glucose, and 1.1 is another threshold. 1.1 millimole per litre threshold is also used. So you can get false negative and false positive results. Patients in particular, and probably more so in this day and age with our sort of epidemic of diabetes, patients with diabetes mellitus or impaired glucose tolerance will have a greater glucose rise, because they don't have a normal insulin response to that glucose that's been absorbed after the lactose load. And so you can get a false negative result in patients with diabetes or impaired glucose tolerance. And patients with delayed gastric emptying or accelerated gastric emptying for one reason or another can also have false positive or negative results, respectively. So it's not a perfect test, the lactose tolerance test.
Now, there is an alternative test for chemistry. It's called the hydrogen breath test. Now, how does this one work?
Yeah, look, I think this is a test that is in many ways better than the lactose tolerance test, and in some ways is superseding it, although in our country, Australia, it doesn't attract a Medicare rebate. So most patients will still have the lactose tolerance test as a first-line test. So as with the lactose tolerance test, the patient's given a lactose load orally, but instead of having a series of blood tests, they breathe into a balloon, which is sealed, transported to the laboratory. Hydrogen gas is then measured, and if present above a particular cutoff, indicates that the lactose load, rather than being fully absorbed in the small intestine, found its way to the large intestine, where it was acted upon by gut bacteria, as we talked about earlier, to produce hydrogen gas. And therefore, if that hydrogen gas is present above that cutoff, it indicates that lactase deficiency is present. In other words, lactase activity is deficient, to put it another way. Again, just as with the lactose tolerance test, documentation of symptoms occurring in response to the lactose load is a key part of the interpretation of this test. So the patient should document any symptoms they experienced in response to the lactose load in order to put those two components together, the biochemical finding of hydrogen gas in their breath, along with indicating a lactase deficiency, along with the symptoms to indicate that is also the cause of their symptoms.
The hydrogen breath test, we tend to reserve more for children. I'm not quite sure if that's the same in Western Australia. It tends not to be sort of routinely done in just collection centres here. So we sort of say, and this is probably, I'm not sure, do they do serial breath tests, or is it just a once?
It remains a better test in adults as well as in children. And partly in children, it's better because it's more acceptable. Doesn't involve a series of blood tests. In adults, it does still have better sensitivity and specificity, but because there's an out-of-pocket cost, it just tends not to be used first line. If there was a Medicare rebate for it, my feeling is that we would recommend it for just about everyone.
Now, there are some other tests I came across, things like reducing substances, stool acidity, intestinal biopsy, which again, are these useful at all, or are they second line, or where do they sit?
The stool tests are not very reliable, and so they tend not to be used these days. Intestinal biopsy whereby a gastroenterologist gets a biopsy of the small intestine and tests, and then the pathologist can test it for lactase activity, can be done. But you can get false negative results if the lactase deficiency is is not spread uniformly across the mucosa. So you might miss a spot of lactase deficiency, if you like. And unlike the lactose tolerance test or the breath hydrogen test, you're not giving a lactose load, so you can't correlate the symptoms with what you might find on the biopsy. And of course, it's invasive, expensive, time-consuming, and all those things as well. So it's not very commonly done, but it can be done.
There is another section we're going to talk to Dr. Melanie Galea just regarding genetics testing for this. If you were to have testing just personally about lactose tolerance, would you go down the chemistry path or the genetics path?
Look, not that this is battle of the pathologists, but I would personally, I would start with the breath hydrogen test. That would be my first line test.
Any final thoughts, Michael, or advice for doctors or our listeners in this field?
Yeah, look, I think, Steve, that lactose intolerance does remain a fairly challenging clinical disorder to diagnose. There's no perfect test. The breath hydrogen test is in many cases the best first-line test, although, as we've spoken about, does carry an out-of-pocket cost in Australia. But the documentation of the patient's symptoms in response to a lactose load is really key, along with improvement in longitudinal symptoms after several weeks of lactose-restricted diet. Those are the things that will really help to establish the diagnosis. And again, if the patient feels better off lactose and they're happy with almond milk in their frappuccino, and their symptoms have improved, then that's a good result.
I really can't wait till this episode comes out, because I have gently teased my wife for a long time, who says she is lactose intolerant, except when it's dessert time for some reason. And your chat today has suggested there is plenty of nuance in this field.
Look, I haven't tried almond milk ice cream. I suspect I wouldn't enjoy it greatly. But there's lots of options out there.
There are indeed. Dr. Michael Page, thank you so much for joining This Medical Life.
Anytime.
Dr. Melanie Galea is a genetic pathology specialist and Director of Genetics at Douglas Hanley Marr Pathology in Sydney. She's trained and worked in clinical public and private laboratories in New South Wales and Queensland. Dr. Galea is a member of the RCPA Genetics Advisory Committee and served on the Evaluation Subcommittee of the Medical Services Advisory Committee. She has an active role in genetic pathology training and supervision and was the inaugural RCPA National Coordinator for Genetic Pathology Training. And Melanie, we welcome you as a guest on This Medical Life podcast.
It's a pleasure. Thank you for having me.
Oh, we are intrigued by this topic coming up, and I'd like to start by asking just how common is lactose intolerance, or if I take the other side of the coin, lactose persistence?
So as Dr. Page has covered, there are several different types of lactose intolerance. When it comes to lactose intolerance due to lactase non-persistence, this is very common. It is estimated that approximately 2/3 of the population worldwide are affected by this condition. I should note that there is another extremely rare genetic condition, congenital lactase deficiency, which is caused by variants in the LCT gene. And this shows an autosomal recessive inheritance and presents in early infancy.
So if we're looking at the genetics, do we have a good understanding of what races are intolerant or persistent?
So there certainly is a link to certain populations that were reliant on milk products for nutrition, and so there is an evolutionary connection with lactase non-persistence.
You mentioned the genetic, the congenital one, which I believe is very, very rare, as you mentioned.
Yes.
Then how do people lose their ability to tolerate lactose?
So in most people, production of the lactase enzyme from the LCT gene gradually decreases after infancy to very low levels by adulthood. And this reduced production of lactase results in the inability to digest lactose and therefore results in those clinical symptoms that Dr. Page would have discussed earlier.
When we're looking at the molecular mechanism of intolerance, is that something that it just reduces so low that people start to get symptoms, is it?
That's correct. And this type of lactose intolerance typically presents in adulthood.
Right. So what age are we sort of expecting people to become intolerant?
Generally, it's in adulthood when the production of that lactase enzyme is reduced.
So when we're actually testing, so we've got the chemical tests where we actually test for, pretty much conversion from lactose to glucose. What are we testing when we're actually testing for a genetics lactose intolerance?
The gene that encodes the lactase protein is called LCT, and it is located on chromosome 2. And there are some upstream regulatory elements in the adjacent gene, MCM6. And these elements regulate the expression of the LCT gene. Several variants have been identified in this region that can result in the continued production of lactase into adulthood. And it is assays that these variants that the assay is designed to detect. When we're doing the genetics test, we are testing for those particular variants. And this is a genetic test which runs against the usual paradigm with genetic testing. In this test, the detection of variants can rule out a diagnosis. So in this case, detecting these variants means that the patient does not have lactase intolerance due to lactase non-persistence.
Okay, I'm trying to weigh that's sort of almost a double negative. I'm just trying to how do we say that one? I'm just trying to think. So
it's interesting, isn't it? We often have many conversations with doctors around the interpretation of this test because it's the opposite of what you would typically expect. Yeah. So finding variants in this gene is a good thing because it means that we are ruling out that diagnosis of lactose intolerance due to lactase non-persistence.
Can you explain a little bit about the inheritance pattern? Because clearly you can have two parents that can be intolerant. Does that mean you'll have an intolerant child automatically? Is this Mendelian? Is this autosomal? What kind of pattern is this?
So as I mentioned before, the LCT gene is on an autosome, chromosome 2. Lactase persistence is an autosomal dominant trait. So typically a person would inherit one copy of the LCT gene from their biological mother and one from their biological father. The presence of one version of the gene with a variant that allows expression of lactase into adulthood is sufficient to lead to lactase persistence. So if both parents have lactase non-persistence, then all of their children will have lactase non-persistence and therefore lactose intolerance.
Can this test be affected? Because there is such a thing as secondary lactose intolerance. So if someone gets an infection, their gastrointestinal system clearly loses a little bit of the lactase ability to process. So they can feel a little bit of symptoms from having milk after an illness. Is this affected? Does this affect the test at all?
Essentially, no, as this is a germline genetic test. With this test, we are extracting genomic DNA from nucleated cells in either a peripheral blood sample or a buccal swab taken from the patient, and we're testing for specific sequence variants within this DNA. This test is not impacted by any recent infections or secondary lactose intolerance. There are rare instances, however, for example, if a patient has had a stem cell transplant, where the test may not be reliable.
What sample do we take for this test? Is this blood or is this a buccal swab? What do we take?
So the test can be performed on either a peripheral blood sample or a buccal swab. The samples can be stored at room temperature and then delivered to the laboratory for testing.
How long do the results often take?
The turnaround time for lactase genotyping is typically 1 to 2 weeks.
Now, the interesting part is the chemistry tests are covered by Medicare in Australia, but the genetics test is not. What's the cost for this?
You're right. There is no Medicare rebate available for this test. And so patients do have to pay an out-of-pocket fee for having this test performed. The test would vary with the laboratory that is performing the test. So we would advise doctors to contact their laboratory of choice to ask for costing.
If a patient shows lactose persistence via the genetics test, can they become intolerant a few years later?
Yes, they could. So they would not be presenting with lactose intolerance due to lactase non-persistence. However, the presentation could be due to other causes of lactose intolerance. For example, that secondary hypolactasia you mentioned earlier.
I should have put a warning at the beginning of this episode not to drive while listening, because you need to pay attention to every word. Melanie, just one quick question as a layperson here, noticing that the appearance of lactose intolerance can tend to increase with age. Is that related to what you hear on the internet, that only infants are meant to drink milk and so therefore as you're an adult you're not meant to? Is there anything tied up with that, do you believe? Let's get into some pop science.
Oh, that's an interesting question. I think biologically, 2/3 of us are designed not to digest lactose into adulthood. And so what the reasons are behind that is for conjecture and anyone to guess. But that's where we're at. We just aren't able to.
Yeah. And actually, you just reminded me right at the very beginning, Dr. Travis Brown got me aware of the cultural bias that we think drinking milk is natural, but population-wide over the whole world, we're kind of outliers. So there you go. I'm coming from that perspective. Final question. Is there any advice or final thoughts you'd like to share with doctors or patients on this topic?
So we understand that it is a very confusing area, but essentially lactase persistence genotyping is a useful tool in ruling out lactase non-persistence as a cause for an adult patient presenting with symptoms of lactose intolerance.
Melanie, you must be very good at doing that sort of pat your head and move your head, because keeping all those negatives and double negatives, wow.
I know. It is, but we have so many conversations with referrers because, as you can imagine, it's quite difficult to produce a report that simplifies that complexity. And it's because of the, lactase, lactose, persistence, non-persistence, tolerance, intolerance, and all of that comes into play. So yes, it's you just need to take it slowly, I think.
Beautiful. Dr. Melanie Galea, thank you so much for being on This Medical Life.
My pleasure.
This Medical Life is recorded in the Talked About Marketing Studios in Adelaide. For show notes and more information about the podcast, visit thismedicallife.com.au. You can contact the hosts on social media. Dr. Travis Brown can be found on X. His username is @DrTravisBrown. That's Dr. Travis Brown. And Steve Davis can be found on LinkedIn. Go to linkedin.com/in/TheRealSteveDavis. This has been a Pathnotes Proprietary Limited production.